This lesson is to show an example of estimating a division problem. I'm going to use something similar to what we had in class today, and this is spring semester 2014, if this video lasts for a long time, but the discussion was really good, so I want to use a similar example. I don't remember the exact numbers, but it was something like 71,489.28 divided by 58. So what we're learning to do is, for a first step, simply round the divisor, the number you're dividing by, to one significant digit, just to have something to start with and something to work with, because the point of what we do next is to look at multiples of that divisor. And granted, there's a 0 there, but the 0 we'll deal with kind of later. And so what we look at is multiples of 6. So I start to count by 6s, 6, 12, 18, 24, 30, 36, 42, 48, and I'm getting pretty big here. 54, 60, 66, 72, and I'm on purpose going beyond where you might typically think to go, just to look at some of the things that happen. So when we're looking for a multiple of 6, actually the very first one here is potentially appropriate to round this off, this 71,000 some odd, round it off to 60,000, and right away get an estimate. Well, 6 divided by 6 is just 1. And now looking at the zeros, I've got to have 3 zeros on that, so that 60 times 1,000 has 1 0 in the 60, 3 zeros in the 1,000, for a total of 4 zeros in the product if you're checking by multiplying back. So in my mind, there's really nothing wrong with that estimate. It's definitely easy to do, and it's relatively close to what the actual quotient is. But let's look at some others as well. So I'm going to go ahead and write the 70, whoops, back up. I want to keep my color coding. So the 71,489.28, and assume we've already rounded to 60. But now when we start looking at the multiples, 6, 12, 18, 24, 30, 36, 42, 48, 60, 60, oh, I forgot one, 54, don't forget good old 9 times 6, 54, 60, 66, and 72. What we often do when we're looking at multiples of that one digit is look at 2-digit multiples of that one digit, and the typical problem has us looking at the two numbers that these first 2 digits, in this case 71, are in between, and deciding, okay, which of those two makes sense to round to. And I think that 71,400, is pretty close to 72,000, and it seems odd to those of us who have been, hey, we're rounding to the nearest 1,000. Well, no, we're not. If we rounded to the nearest 1,000, it would be 71,000. So we're not doing that. Again, we're rounding to the nearest multiple, and this is a much more accurate estimate than the one we did before. We're getting 1,200 now rather than 1,000. So I like that. Not as accurate, but still acceptable in my class anyway, is if you chose the other one, though not as close, it's still a nearby multiple. And in this case, you get 1,100.